I'm Anil Kumar, and on request of some subscribers, I've taken up a very special question on functions. The question here is determine whether each relation is a function or not and list their characteristics, including domain and range and behavior, increasing, decreasing interval, symmetry, etc. So we started with a set of 6 questions. This is the part B, the second equation, which we'll discuss in details. Equation given to us is x squared plus y equals to 1. We know this relation is a function since we do not have y square in the equation, right? So if there is only y, then it is a function. So that is kind of our approximate test for making an equation or understanding from the equation that it represents a function, right? Let us rearrange and then we'll know more about it. Y is equals to, we'll take x squared to the right side, becomes minus x squared plus 1, and that is a parabola. Let's sketch this function. So minus x squared means moving downwards and plus 1 means translated 1 unit up. So we can actually sketch it like this. Now clearly this is a graph of a function since it passes vertical line test, right? So it passes vertical line test. It's kind of a review for you also. From a graph we can do vertical line test. That means drawing a vertical line, it only intersects at one point. So that clearly shows that this relation between x and y is a function, right? So any x value is uniquely associated with just one y value. So that's the whole idea. So now we know it is a function. Let me write down it is a function, correct? Now we'll discuss characteristics of this particular function. We'll begin with domain and range. Domain in this particular case is x belongs to real numbers. Written in curly brackets gives us set, right? Range is we need to find the vertex. So it is opening downwards and therefore the range is y belongs to real numbers where y is less than equal to. If I write 0 here, then y value is 1. So this is 1 for me. So less than equal to 1. Now we can find the x and y intercepts. We can say from other characteristics what is x-intercept. X-intercept is a point where y is 0, right? So if I write y as 0, so we can calculate 0 equals to minus x squared plus 1. So if that gives me x is equals to plus and minus 1. So x-intercepts are at x equals to plus and minus 1. Similarly, let's find what y-intercept is. Y-intercept is a point where x is equals to 0. Substituting x equals to 0, we get y equals to minus 0 squared plus 1, which is indeed 1. So x-intercepts are plus and minus 1 and y-intercept is just plus 1. So that is a part of characteristics. Now let's look into end behavior. End behavior really means how does the function behaves as x value is very large. That is to say, when x is very large negative value, what happens to y value, right? And also when x is very large positive value, what happens to the y value? You can see from here, if x is very large negative value, y is very large negative value, right? Since the parabola opens downwards, it always, going towards negative infinity. When x is very large positive value, y is very large negative value. So we can write this as negative infinity. So that is the end behavior. And now we'll talk about increasing and decreasing interval. So as far as increasing interval is concerned, you need to see the graph from left to right, always from left to right. So it increases till x equals to 0. So you could say it is from minus infinity to 0, it is increasing. Decreasing interval. Decreasing interval is from 0 to infinity. So after 0, we have a peak at x equals to 0. After that, it decreases. So it could be written as I have written here. Now we'll talk about symmetry also. This graph is symmetric. It has what kind of symmetry? It is symmetric about y-axis, right? So it is symmetric about y-axis, right? So we call this kind of a symmetry as even symmetry. You could algebraically also check that in this particular case f of minus x will be equals to f of x. That is to say, if I replace x with minus x, we'll get the same expression, correct? Because square of a negative value is positive. So, and when we say that it has even symmetry, that means if we consider 2 points, if we consider this y-axis as a mirror, then we'll see that on a graph we'll have image of every point on either side. So like this, do you understand? So we have even symmetry, minus 1, plus 1. And so it is symmetric about y-axis. So we say y equals to, y-axis, you can say y-axis, or x equals to 0 is line of symmetry. Right, so that is how we can summarize some of the characteristics of this particular function. I hope that really helps. So let's move on to example 3 or part C of this question. Thank you and all the best.